Welcome to Bitcoin, past, present, and future. In this presentation, we'll break down the world's first decentralized digital currency, from its origins and how it works, to its growing adoption, challenges, and what lies ahead. Whether you're new to crypto or just curious about how Bitcoin actually functions, this video will help you understand the key concepts shaping the next evolution of money. We'll explore Bitcoin in four parts. First, what Bitcoin is and why it was invented. Then how it works, including blockchain, wallets, and mining. Next, we'll look at adoption and challenges shaping Bitcoin's global role. And finally, we'll end with the future outlook, where this technology may be heading in the next decade. Bitcoin was created in 2008 by an anonymous figure under an alias. It's not issued by any bank or government. It's purely a digital currency that lives entirely online as ledger entries. The idea was radical: to build money that's borderless, permissionless, and resistant to control. Instead of relying on trust in banks, Bitcoin relies on mathematics, cryptography, and distributed consensus. Unlike traditional banking systems that rely on intermediaries, Bitcoin operates on a peer to peer network. This means that two people can directly send value to each other, anywhere in the world, without approval from a bank or a government. Another key feature is scarcity. Only 21 million Bitcoins will ever exist. This fixed supply enforced by code makes Bitcoin deflationary by design, earning it the nickname digital gold. As central banks print more money, Bitcoin scarcity offers an alternative store of value for many investors. Fiat currencies like the US dollar are controlled by central authorities who can change monetary policy at will. Bitcoin, however, is governed by decentralized consensus. No single entity can alter its supply or censor transactions. Direct peer to peer transfers also reduce fees, increase accountability, and provide individuals with complete control over their funds, especially in regions with unstable financial systems. At the heart of Bitcoin lies the blockchain, a public distributed ledger that records every transaction ever made. Each new block contains a list of recent transactions, linked securely to the previous one, forming an immutable chain. Because the blockchain is stored on thousands of computers worldwide, it's nearly impossible to alter, ensuring transparency and preventing fraud. This system replaces the need for a trusted central database with a network that verifies itself. Bitcoin security comes from cryptography. Transactions are locked using digital signatures, and ownership is proven through cryptographic keys. To maintain agreement across the network, Bitcoin uses a consensus mechanism called proof of work. Miners compete to solve complex puzzles, validate transactions, and secure the blockchain. This process ensures that all nodes agree on a single version of truth, without needing any central authority. Every Bitcoin user has two keys: a public key, like an address that you can share to receive money, and a private key, which must remain secret because it grants ownership of your coins. Wallets help users manage these keys, allowing them to send, receive, and store Bitcoin safely. Think of a wallet not as holding coins, but as holding proofs of ownership stored on the blockchain. Bitcoin mining plays a crucial role in maintaining decentralization. Through proof of work, miners validate transactions, add new blocks, and earn block rewards, which are newly created Bitcoins plus transaction fees. This incentive system keeps the network secure and self sustaining. Because thousands of miners complete globally, no single actor can control the blockchain, which makes Bitcoin one of the most secure networks ever created. Here's what happens when you send Bitcoin. Your transaction is broadcast to the network, verified by nodes, and collected into a pending pool. Miners then include it in a block, which, once confirmed, becomes a permanent part of the blockchain. The more confirmations it receives, the more secure it becomes, preventing double spending or fraud. Bitcoin's use cases have expanded far beyond speculation. It's now used for cross border remittances, enabling faster and cheaper international payments. In countries suffering from hyperinflation, Bitcoin acts as a hedge against devaluation. Nonprofits use it for transparent donations, and developers are integrating Bitcoin into decentralized finance, creating new systems of lending, trading, and payments that don't rely on traditional banks. Bitcoin still faces many major challenges. Its base layer handles only a few transactions per second, leading to congestion and high fees. Layer 2 technologies like the Lightning Network aim to solve this by allowing instant micropayments off chain. Another concern is energy consumption. Proof of work mining consumes large amounts of electricity, sparking debate over sustainability. Supporters argue that much of this energy comes from renewables, and that Bitcoin's security and independence justify the cost. Around the world, governments view Bitcoin differently. Some countries restrict it or ban it entirely. Regulation is evolving fast, and it covers taxation, anti money laundering, and exchange compliance. Initiatives like EU's Markets and Crypto Assets framework aim to bring clarity, while projects like Project Crypto in the US seek balanced regulation that fosters innovation without stifling growth. The Bitcoin network continues to evolve. Upgrades will improve privacy, compress transaction data, and make multi signature wallets more efficient. Meanwhile, Layer 2 innovations will boost scalability, enabling millions of instant transactions per second, while preserving decentralization. Many analysts believe Bitcoin will eventually mature into a global digital gold. Its scarcity and independence from governments make it a long term store of value and a hedge against inflation. However, its price volatility remains a challenge. Events like the Bitcoin halving, which cuts mining rewards every 4 years, also shape its supply dynamics, often triggering new market cycles. Like any disruptive technology, Bitcoin carries both risks and opportunities. Price swings can be extreme, and bugs in the underlying protocol could threaten network stability. The future development of quantum computing may also challenge current cryptographic methods, pushing research into quantum resistant solutions. On the other hand, Bitcoin offers opportunities for financial inclusion, censorship resistant payments, and portfolio diversification, which extend beyond pure profit. Thank you for watching this video about Bitcoin, where we explore its past, its challenges, and the possibilities that define its future.